Think about a single piece of craft glitter. Now, imagine taking the room you are sitting in, the building around it, the Earth, the Sun, and every galaxy we can see, and compressing all of that matter and energy down until it is smaller than that single speck of glitter. That intensely dense, microscopic point is exactly how our universe existed 13.8 billion years ago. We usually call the moment that followed the Big Bang. The name suggests a fiery bomb detonating inside a dark, empty room. But space wasn't empty. Space itself grew. We call this the everywhere stretch. Moving away from the word bang is important. A stretch describes an active, continuous process of growth, the process that gave the universe the physical room it needed to eventually build everything we know. To picture how this works, imagine a deflated balloon covered in small dots. If you inflate the balloon, the rubber surface stretches. Every single dot moves away from every other dot at the exact same time. The hot, dense environment of the early universe behaved the same way, expanding across all points simultaneously. Because all of these points distance themselves from one another all at once, there is no single center point to the expansion. If you sit on any specific dot on that balloon, it looks like everything else is rushing away from you. Any coordinate in the universe appears to be the center. People often ask what the universe is expanding into. The universe generates new space as it stretches. The very fabric of space is stretching and carrying objects with it. This exponential stretching had a direct physical consequence. By forcing all that concentrated heat and energy to spread out over a larger and larger volume, the early universe finally began to cool down. In the extreme heat of the very beginning, subatomic energy particles were moving too fast to stick together. As the temperature dropped, these particles were able to slow down enough to physically bond with one another. These newly bonded clusters became the very first atoms. At this stage, the universe was almost entirely filled with just two basic elements, hydrogen and helium. Over millions of years, the invisible force of gravity began to pull these massive clouds of basic atoms together. The clouds became denser and denser until the internal pressure squeezed the hydrogen atoms so tightly that they were forced to ignite. Without the initial stretching of space, the extreme heat of the beginning would have remained too high for atoms to bond, or for the first stars to materialize. The early universe only manufactured basic hydrogen and helium gas. This fact raises a question. Where did all the complex solid materials for rocky planets, tall trees, and human beings come from? The cores of the first stars acted as high-pressure cosmic ovens. The immense gravity squeezed the basic hydrogen and helium atoms together so intensely that they fused, creating heavier, more complex atomic ingredients. For these ingredients to build a solar system, the first stars had to die. They ran out of fuel, collapsed, and exploded violently. These massive explosions scattered the newly cooked heavy elements across the void of space. Those scattered clouds of complex dust and gas provided the raw materials needed to form new solar systems. In our universe, destruction is a creative prerequisite. The explosive death of the earliest stars was required to supply the iron in our planet's crust, the calcium in our bones, and the oxygen in our lungs. Scientists prove this story by using advanced orbital telescopes. These tools allow us to look deep into space and detect the leftover radiation from the early universe's rapid expansion. This timeline visualizes the entire history. On the far left is the initial flash of energy. Moving right, we see the cool down forming the first stars and our solar system. On the far right edge, we see the current state. Space's expansion is accelerating. Every atom that makes up your body was forged inside a star and scattered across a growing universe. You are constructed from recycled star stuff. The origin of the universe is an active, continuous stretch that we are living inside today.